All right, so I wanted to make a short video just to kind of go through some of the topics that you'll see in week one here for Chem 1154. So I'm just going to go through some practice problems, especially if you're encountering any issues with completing this particular assignment. You can maybe follow along and use some of the hints as I go through. All right, so the first one here, again, with the first couple of weeks of the class is mostly math. So it's a bunch of math review that we're doing. So here it's giving you negative 7 over 8x is equal to 49, right? So this can also be written as follows. Negative 7x over 8 is equal to 49. And here we need to solve this for x, right? So the goal here is to isolate x on one side of the equation and move everything else to the other side. So what we can do is we can cross multiply this way, and then 49 is the same as 49 over 1. We can cross multiply that way. So cross multiplication is one of the tools that you can use in math, and we'll use this again when we get to the gases chapter down the road. So when I multiply this way, right, 1 times negative 7x gives me negative 7x. And then when I multiply this way, I get 49 times 8, right? So I might need a calculator for that. So 49 times 8 gives me 392. Let me see if I can do this in a different color. So that way it gives me 49 times 8. So that's 392. That's equal to negative 7x. Now again, I want to isolate x on one side, so I can divide then left side of this equation by negative 7 so that the negative 7 cancels. And in an equation, whatever you do to one side, you need to do to the other side. So I need to divide the other side by negative 7 as well. So then I end up with x being equal to 392 divided by negative 7. And that gives negative 56 as my answer. And the way you can check your answer is you can go ahead and you can plug this value back into the original equation, and you should get your original answer. All right, the second one, very similar to the first, except now it's using addition versus multiplication and division. So here we have negative u plus 285 is equal to 9. All right, and some of these are obviously, simpler than others. Here again, we want to solve this for u. This thing here, we want to isolate u on one side of the equation. So what we can do is we can take this and we can move this to the other side of the equality sign. So I end up with 285 is equal to 9. When you move things from one side of the equation to the other, you need to change the sign. So we move this then to the right side. This becomes plus u. All right, so we've maybe made it simpler, but maybe not quite. We still need to just get u on this one side. So if I need to get rid of the other thing here, which is the 9, I can move this to the other side. So I end up with 285 now. And whenever you have a number here, the plus sign in front is understood. When we move it across, we need to change the sign to negative 9, and that's equal to u. So 285 minus 9 then would give us 276. And that's equal to u. All right, here the next one we have multiplication and specifically exponents. So we have 2x in parentheses cubed, and it says to simplify this. So when you have your 2x and this is to be cubed, what that means is we're going to multiply 2x by itself 3 times. Right, so this is what that actually means. So we can do it a couple ways. We can do the 2 times 2 times 2. So that's 2 to the 4 times 2 is 8. And then x times x times x is x cubed. And that's your simplification of that thing expressed with those parentheses. All right, we have integer multiplication and division. And again, this really has to do with, how you treat your signs, positive, negative signs when you multiply and divide. So if you take a look at the first one, we have -2 times -7. So we can multiply the actual numbers first. 7 times 2 is 14. When you multiply two signs that are the same, we end up with a positive sign. So that ends up being positive 14. I have 72 divided by -9. This is the same as saying 72 divided by -9. 72, if you don't see a sign, positive is understood. So 72 divided by 9 gives you 8. And then if you have a positive divided by a negative, or a negative divided by a positive, we end up with a negative sign. All right, let's jump down to density and masses and volumes. So it says using mass density to find mass or volume. And we'll just sort of reiterate a couple things. So density is defined as the ratio of a substance's mass to its volume. All right, so this is expressed mathematically. D for density is equal to M mass over V volume. And it says that a chemistry student needs 15.0 grams of acetone for an experiment, and it says to consult the CRC Handbook of Chemistry and Physics. The students discover that the density is 0.790 gram times centimeter cubed to the -3. And it says calculate the volume. Of the acetone that they should pour out. All right, so a couple of things to keep in mind here. What we need to find in this problem is the volume, right? So what we need to determine is V, which is this thing, which means we should be given the other two components, density, and we should be given the mass. Well, yes, the mass is given to us here. We need 15 grams, and the density, we're told what that is by looking up in that book, 0.790 grams times centimeter to the -3. So a couple things about this unit. Okay, this is the same as saying grams per or grams over centimeter cubed, grams per cubic centimeter. This little dot here just means times, and then centimeter to the -3 means 1 over centimeter cubed. Right, so that's another way you'll see these density units being represented. It's very easy to get flustered when you see that. This is all that it means, gram per cubic centimeter. And as you watch the videos, you'll also see that a cubic centimeter is the same as a milliliter, ml. So this can also be written as gram per milliliter. Okay, they all mean the same thing. All right, so we decided that we need to determine the volume that we're dealing with. We're provided with the mass and the density. So we can take our density equation, D equals M over V, and we need to solve this for volume. Okay, so this involves a little bit of manipulation of this equation. We want to isolate V on one side. Again, we can cross multiply this way. So we have D times V is equal to, and then cross multiplying this way. Right, remember when you have something by itself on one side of the equation, that's the same as saying that it's over 1. So that is equal to M. So if I need to solve this for V, I need to then, to isolate V on the left side, we need to divide this by D. And then I need to divide the right side by D as well. So D cancels. Volume then is equal to mass over density. I can then substitute the numbers that are given. The mass there is 15 grams, 15.0 grams. And then the density is given as 0.790 grams per cubic centimeter. All right, so if I evaluate this, right? This is the same as saying 15.0 grams times cubic centimeter over 0.790 grams. So my grams can cancel, and I end up with cubic centimeters my unit, which I want, right? I needed volume, and cubic centimeter is a unit of volume. I can then evaluate this, whatever this happens to be. I have 3 sig figs here, I have 3 sig figs there, so whatever my number I get you should round it to 3 significant figures, right? So you want to pay attention to that when you perform your calculations. All right, and then the next one here, we're looking at converting units. And this is really just asking about how you would set up a particular conversion, a unit conversion to be more specific. So we're provided with units here of grams per mil. We want to end up with grams per liter, right? So the only unit that we're trying to convert here is the milliliter here on the bottom. So we want to convert mils to liters. So we need a conversion factor that we're going to insert here that will allow us to go from mils to liters. So what's the relationship between milliliters and liters? That's a metric relationship. 1 milliliter equals 1,000 mils equals 1 liter. That's an equality that we can set up with 2 different conversion factors. Right? We just put one side of the equality over the other. And then the question then becomes, which of these are we going to insert in here so that I end up with liters on the bottom, right? And obviously, the one on the left has liters on the bottom. Mils go on top, and we would want to use that one because milliliters can cancel away. All right, and then the next one looks at incorporating dosages and specifically determining how much medication was administered to a patient. So it says here that the bottle is labeled for the solution 300 milligrams in every 5 milliliters of the solution, right? So if you take 5 mils, you get 300 milligrams of this particular medication. The patient says that he's taken 4 mil doses in the past 24 hours. So 4.00 mil doses. So this would be 4 times 4 is 16. 0.0 mils in that 24 hours. Okay, and we need to figure out what's the total amount of this drug that he's taken in that 24 hours. Well, we've just determined the total volume taken. This is the dosage in terms of milligrams of the drug per volume. So I have my dosage, and this is the total volume taken. And what I need to find is the total amount of milligrams, right? I need to get how much is taken. So I can use both of those things, the dosage together with the volume to determine the mass. So I can start with the dosage, 300 milligrams per 5 mils. Did the patient take 5 mils? No, he took a total of 16 mils. So I can just multiply it by 16. Mils, I put it over 1. And the reason why I would multiply is because I want the mils to cancel, right? And that's your clue that you're using here to decide what goes where with your conversion. And if you look now, the only unit left is milligrams, and that's what you wanted to find, right? You need to find milligrams as the unit. You can multiply this out and then evaluate it, and round it to the nearest milligram. All right, and then the next one, we're looking again at dosages. And again, most of you are going into allied health or nursing, and you're going to be administering drugs to your patients. You need to make sure that you're giving your patients the correct amount so you don't overdose them or you don't give them enough, as much as they need. So a couple of these questions here, kind of dive into some of the dosage calculations. which uses a lot of these unit conversions and metric conversions that you're learning in this first week. All right, so the first thing we're told is that we have a 82 kilogram patient. Okay, and it's a good strategy to write down all the information that's given. And then the prescription says that he should be getting 12 mcg. So mcg stands for microgram per kilogram of body weight, right? So mcg here is, and this is the same as the metric symbol for, well, the symbol for micro, which is mu, that you'll see in your textbook. mcg is used a lot in healthcare settings. So that's the prescription. That's how much it's telling us for every kilogram of body weight, he should be getting, or this patient should be getting, 12 micrograms of this particular atrial fibrillation drug. And then the drug itself is available in a particular makeup or a particular solution. And the drug itself comes in concentration of 50 micrograms mcg per mil of that drug, right? So milliliter suggests that it's a volume, so it's something that, it's a liquid that the patient's going to take. And the way that it's made up is that for every milliliter that they drink, there's 50 micrograms of that particular drug. Now, the drug itself needs to be administered administered via body weight. For every kilogram of body weight, they should be getting 12 micrograms. So we need to figure out, based on the weight of the patient, how much of the drug they actually need, right? So we can start with this. We have our 12 micrograms per kilogram of body weight. The patient is 82.0 kilograms. Okay, so I can multiply this out and I can figure out now how much actual drug does the patient need. So 82 times 12 would give 984 micrograms of the drug. Well, how is the drug administered? The drug is administered this way, right? It comes in a solution that says that you need to drink a certain amount of it, and in every milliliter that you drink, you get 50 micrograms. So now I'm going to take this relationship and incorporate it. I have my 984 micrograms that I need this patient to get per day, and I'm going to use the formulation of the drug that tells me that for every 1 milliliter, and I'm putting mils on top, that the patient takes, he's going to get 50, or they're going to get 50 micrograms of the drug. I put micrograms on the bottom. Why? Because I want the unit to cancel, and because I'm asked specifically to get the volume in milliliters. So I want mils on top. Okay, so I can just divide this out, get 984 divided by 50, and then that gives me whatever this happens to be. It says to round it to the nearest mil. Okay, you can do that and round it accordingly, according to the rules of rounding.